Yo, what's up, guys? It's Bamber here, and today we're going to be reacting to this planet can prove we're not actually alone in the galaxy. Let's see what they're about.
For centuries, we've looked out to the stars and wondered, are we really alone? Now we might be closer than ever to finding out. In April of 2025, the James Webb Space Telescope picked up mysterious signals from exoplanet K2-18b, located just 124 light-years away.
What? That's
Those
crazy.
signals revealed something extraordinary: chemicals in the planet's atmosphere that are essential for life as we know it. While it's not confirmation of aliens just yet, it's the strongest clue we've ever had that life might not just exist,
Let me know
but
in the
might be
comments if you
common
guys
in the
find this
galaxy.
interesting or
The
not. I do.
K2-18b exoplanet was discovered by NASA's Kepler mission in 2015. Then in 2019, the Hubble Space Telescope detected what appeared to be water vapor in the atmosphere. And where there's water, there just might be life, or at least the conditions to support it. Recently, the James Webb Space Telescope, launched in 2021, was directed towards the planet. By observing how starlight passes through the planet's atmosphere, the telescope allowed scientists to identify specific molecules based on the unique wavelengths they absorb. While looking at K2-18b, astronomers believe they have identified two chemicals: dimethyl sulfide, or DMS, and dimethyl disulfide, DMDS, which are compounds that on Earth are only produced by life. The concentrations also seem to be thousands of times stronger than on Earth, which might suggest that the exoplanet is teeming with life. This discovery also provides us with a new potential method for detecting habitable and habituated planets. Moreover, considering how close K2-18b is to us in the enormity of the galaxy,
Booking.com has all kinds of stays. Because what's right for some
That a mirror?
might not be right for others. Find exactly
Alright,
what
let's
you're
go wait for
booking
this
for.
ad.
Booking.com, booking.yeah.
Get AHM Extras
another ad.
cover from just $3.40 a week. It's a no-brainer. With AHM, you're good.
it could suggest
Alright,
that
here we
we
go.
are far from alone in the universe. K2-18b didn't exactly top the list of anyone's likely home for alien life. From Earth's point of view, it sits in the Leo constellation, orbiting a dim red dwarf star known as K2-18, or more formally, EPIC 2019-12552. Red dwarfs are the quiet workhorses of the universe, making up about 73% of stars in the Milky Way.
Alright,
They
that's-
burn cooler, slower, and fainter than our sun, with low mass, low pressure, and a relatively sluggish fusion rate. And you won't spot one in the night sky with the naked eye. The star has two planetary companions, the first of which is K2-18b. The other planet, K2-18c, is probably a gas-rich Neptune-like planet with an
Sorry,
orbital
guys.
period of just 9 days. K2-18b is a transiting exoplanet, which are planets that orbit stars outside of our solar system and between the Earth and its sun, increasing its observability from the Earth. K2-18b has a mass 9 times that of Earth, and it has a radius 2.37 times that of Earth.
Alright,
It has an orbital
wow.
period of 32.9 days. Because of its size, K2-18b is classed as a sub-Neptune. The planet's interior likely contains a large mantle of high-pressure ice, like Neptune, with a thinner hydrogen-rich atmosphere. For this reason, these large planets often aren't considered candidates for life. But K2-18b is also called a super-Earth, because the distance from its star means that it sits in the habitable zone, where temperatures that create liquid water could exist. Because its red dwarf sun is significantly cooler than our own, K2-18b sits significantly closer to its star, with an orbital radius of 0.1429 astronomical
Wow.
units, or AUs, compared to the Earth's 1 AU from the Sun. All of this is why the James Webb Space Telescope project, led by Professor Niku Madhusudan from the University of Cambridge, were interested in K2-18b. Initial observations indicate that the hydrogen-rich planet might have water vapor in the atmosphere, as well as methane and carbon dioxide, but without the presence of ammonia. This could be suggestive of large oceans deeper than those on Earth, underneath a hydrogen atmosphere. Madhusudan leads the Hycean Worlds Project, a cutting-edge initiative focused on studying exoplanet atmospheres. His team combines advanced telescope observations, powerful atmospheric retrieval techniques, and in-depth modeling of the physical and chemical processes at work in exoplanet atmospheres, interiors, and oceans. Using the James Webb Space Telescope, Madhusudan's team is zeroing in on Hycean worlds, a class of exoplanets they proposed.
What do you guys think of this so far? I find it pretty interesting, actually. And, you know, there's a lot of conspiracy theories and lots of people talking about, is there another life out there? Let me know in the comments what you think. Is there another life out there, or do we just, think of it differently? I don't know, but we'll continue watching and see what they're saying.
In 2021, these planets are defined by thick hydrogen-rich atmospheres layered over vast global oceans, and K2-18b appears to fit the bill. The presence of liquid water hints at the potential for life, but there is another advantage too. Their hydrogen-rich atmospheres make biosignatures easier to detect than on Earth-like planets, giving us a clearer view into their potential habitability. The potential oceans on KS-18b could be the source of the life signs that scientists now believe they may have identified. This seems even more likely since most of the DMS produced on Earth comes from phytoplankton, microscopic marine algae in marine environments. It's often associated with the smell of sea air. DMDS can be produced by a variety of different organisms, including bacteria, fungi, plants, and animals. For example, an increase in DMDS was detected in Australia following the burning of biomass in bushfires. However, K2-18b seems to be tidally locked, which means that one side of the planet is always facing its star. This means extreme temperatures on either side of the planet, which could disrupt patterns of life. While the potential of locating life just on K2-18b is exciting, the discovery could have further implications. While we don't have any sub-Neptunes in our solar system, they are the most common type of planet in the known galaxy. If they can support life, the number of potential life-supporting planets has significantly increased. While the signals from K2-18b are exciting news, it's part of our longer history of the search for life on other planets. The scientific search for life beyond Earth dates back to the late 19th century, when astronomer Giovanni Schiaparelli reported seeing channels on Mars through his telescope. Percival Lowell further popularized this idea, drawing intricate maps of what he believed to be artificial canals constructed by a Martian civilization. This sparked widespread public fascination with life on Mars, although later and more powerful telescopes revealed these canals were optical illusions or natural features. NASA's Viking landers conducted several biology experiments on the Martian surface in 1976. The labeled release experiment, designed by Gilbert Levin, yielded results that were interpreted by him as evidence of metabolism by microbial life in the Martian soil.
Another ad.
Ooh,
My goodness.
that's Vindaloo giving you heartburn. Zantacket. For all-day heartburn relief that starts to work in 30 minutes. Zantacket!
Listerine kills 99%
another-
of bad
oh my
breath
goodness.
germs. That's fresh. Listerine.
However,
Alright,
the scientific
back to it.
consensus leaned toward non-biological chemical reactions as the more likely explanation, especially given the lack of detected organic molecules by other Viking instruments. But this remains a debated topic. A meteorite discovered in Antarctica in 1996, believed to have originated from Mars, contained microscopic structures that a NASA team suggested could be fossilized bacteria. This claim generated significant excitement, but was met with considerable skepticism within the scientific community. Alternative non-biological explanations for the structures and organic molecules in the meteorite have been proposed, and today the scientific consensus leans away from this being proof of past Martian life. Starting in 2004, rovers found evidence of past liquid water on Mars, including hydrated minerals and geological features indicative of ancient lakes and streams. This significantly strengthened the idea that Mars was once a more habitable planet. In 2012, an advanced Curiosity rover landed in Gale Crater, a site believed to have once been a lake bed. Curiosity detected various organic molecules in Martian rocks, including thiophenes, benzene, toluene, and small carbon chains. While these are the building blocks of life, they can also be formed through non-biological processes. The rover also found further evidence of past freshwater lakes with neutral pH and the presence of key elements for life, specifically carbon, hydrogen, oxygen, phosphorus, sulfur, and nitrogen. Curiosity's also detected seasonal fluctuations in the levels of methane in Gale Crater's atmosphere, and it's currently gathering samples to be collected by a future mission as the search for life on Mars continues. Hopefully, this will significantly contribute to the ongoing discussion about the potential of life on Mars. Astronomers have also been looking beyond our solar system for the potential of life on exoplanets. These are mostly based on the size of the planets and their orbit in the habitable zone around their star. HD 20794d is located about 20 light-years away from our solar system and is
Wow,
orbiting
okay.
a Sun-like star. Larger than Earth, it has an elliptical orbit through the habitable zone. The elliptical nature of the orbit suggests the potential for extreme temperature fluctuations. Gliese 12b is a super-Earth exoplanet orbiting a cool red dwarf star about 40 light-years away. It's within the habitable zone and has an estimated surface temperature that could potentially support liquid water. Its proximity makes a good candidate for future atmospheric studies. Meanwhile, Kepler 62f is located roughly 1,200 light-years away. It's about 40% larger than Earth and orbits a cooler star. Its orbit within the habitable zone suggests the potential for liquid water, and its size hints at the possibility of being a rocky planet with oceans. And Kepler 442b is situated about 1,200 light-years away. This
Wow.
exoplanet is about
big
33% larger than Earth and orbits a K-type star or an orange dwarf. Studies suggest that it might receive enough light to support a large biosphere. Then there's the TRAPPIST-1 system planets, E, F, and G, which are all potentially habitable planets. This system has 7 Earth-sized planets orbiting an ultra-cool red dwarf star about 40 light-years away. Planets E, F, and G are considered to be in the habitable zone and could potentially host liquid water. However, red dwarf stars are known for their intense flares, which could also pose a challenge to life. Astronomers will further study these exoplanets using spectroscopy, which is the study of absorption and emission of light and other radiation by matter. It involves the splitting of light into its constituent wavelengths, which is done in much the same way as a prism splits light into a rainbow of colors. However, it's only in the last 2 decades that we've had telescopes, cameras, and computers powerful enough to achieve the detail and precision needed to examine exoplanets.
find it so
The
cool
first
that
spectrum
technology
analysis of an
has evolved
exoplanet
so
using the
quickly.
Hubble Space Telescope
find that
was
amazing.
published in 2002, showing evidence for vaporized sodium in the atmosphere of an exoplanet called HD 209458b. This technology is now being focused on looking for potential biosignatures of life on exoplanets, with the discovery of DMS and DMDS on K218b being the first example of a successful attempt. For these purposes, scientists use 3 techniques. The first is reflection spectroscopy, which bounces light off the planet's surface or atmosphere. The second is thermal emission spectroscopy, which observes the light produced by the heat of the planet itself. The third is transmission spectroscopy, which watches light that passes through the planet's atmosphere. The James Webb Space Telescope
Interesting.
team conducted transmission spectroscopy on K1218b, analyzing light from its parent star as it passed through the planet's atmosphere. This was only made possible by the extended wavelength range and heightened sensitivity of the Webb telescope. The team hopes to confirm its results using the telescope's mid-infrared instrument spectrograph as part of their next round of examination. Nevertheless, their initial findings in 2023 were accepted for publication in the Astrophysical Journal Letters. The published claims have, of course, drawn critique from other astronomers. Laura Kriedberg, an astronomer at the Max Planck Institute for Astronomy in Germany, says that extraordinary claims require extraordinary evidence and that, quote, "I'm not sure we're at the extraordinary evidence level yet." Similarly, Edward Schweiderman, an astrobiologist at the University of California, added, "It's not a sure thing, and it would not be surprising if the signal went away when other groups reanalyzed the data." Other scientists question whether the DMS signals could be produced by something other than life. Just because they're only produced by life on Earth doesn't mean that it's the same on other planets. The possibility is supported by the fact that
Another ad. Okay, at least we can skip this one.
over recent years, trace amounts of DMS have been found in comets and the space between stars. Though it is unlikely that these traces have the same explanation as the concentration 100,000 times higher seen on K218b. But the extremely large amounts of DMS in K218b's atmosphere also suggests that something non-Earth-like could be happening to produce such vast quantities. It's normal for scientists to be hypercritical of new findings like this that push new technologies to their limits and question established scientific wisdom until they're proven. To confirm discoveries, results must be supported by independent lines of evidence, show strong statistical significance, and rule out non-biological explanations. This level of certainty will only emerge over time as independent teams replicate the original experiments, reanalyze the data, and develop new methods to confirm the findings. It's a process that could take decades, but the scientific community is excited to begin. While the James Webb Space Telescope has yielded impressive results so far, it only has the capability of imaging gas giant planets. Several new types of telescopes are under development, including the giant Magellan telescope that will utilize 7 mirrors, each over 26 feet in diameter, to form an 82-foot diameter mirror, offering a significantly higher resolution than the Hubble. The Nancy Grace Roman Space Telescope is also scheduled to be launched in 2027 to offer infrared wide-angle
pretty soon.
views. NASA's
years.
next flagship telescope will be the Habitable Worlds Observatory, and it'll seek to directly image Earth-like planets in the 2040s. It will
wow.
look for signatures for
So we're quite
oxygen,
long
water
till
vapor,
then.
carbon dioxide, and ozone, all of which are not just biosignatures for life, but for life as we know it. While 2040 might seem like a long way off, scientists will need that time to identify transiting Earth twins that orbit in the habitable zone, as they don't yet have any to analyze. With that in mind, the potential for life on gas planets is even more exciting, and Madhu Sudan and his team have reason to be hopeful. He stated, "Decades from now, we may look back at this point and recognize it was when the living universe came within reach. This could be the tipping point, where suddenly the fundamental question of whether we're alone in the universe is one we're capable of answering." Now go check out Planet X will change everything.
Well,
but
hope
why
you
can't
guys enjoyed this
scientists
video
find
and
it? Or
let me
click
know in
on
the
this video
comments
instead.
what else you want to see. So yeah, I hope you guys enjoyed, and I'll see you guys later.